simple differentiation like what I've shown you. Right? You expand, then differentiate one term, one term, one term like that. So far, this is the only method that you have learned. Differentiate one term by one term. Even if there's a bracket, you expand the bracket, then you differentiate one term by one term. If there is a quotient, division of two different functions, one at the top, one at the bottom, you still do the same thing. You break them up into one term by one term, like this, right? 1, 2, 3. Then you differentiate one by one. But however, the more advanced differentiation, you don't expect the function given to you to be in one term, one term, one term, term by term like that. In other words, it's in the form of a polynomial. So you don't expect them to be like a polynomial. So what you should expect is they have a bracket there. Bracket then raised to a certain power. So this one I've shown you the last lesson where you differentiate the bracket one time, then you differentiate what is inside the bracket the second time. So you differentiate it. So this is the differentiation using the chain rule or differentiate a composite function. There are two more rules that you need to know. One is the product rule, the other is the quotient rule. For product rule, it involves two factors multiplied together. So how does it look like? It looks like something like this. There's one bracket here, there's another bracket. So there is a product of two brackets or product of two factors. So when you want to differentiate this, usually you cannot expand, but in this case you can expand, right? Now when you cannot expand the two brackets, then you have to apply the chain rule. Okay, so how are you going to apply the chain rule to differentiate two different, the product of two factors like this? Okay, so let's say you have two brackets like this. This is the first bracket, and this is the second bracket. Or maybe this is the first factor, this is the second factor. Now, how you differentiate it is this, like this. You differentiate the first factor, the first bracket, x minus 3. What you get if you differentiate x, you get 1. What you differentiate what you get when you differentiate 3, you get 0. So you differentiate the first bracket, you get 1. Then the second bracket here, you just copy down. Don't differentiate. Okay? Okay, so this is the first part. The second part is, just now you differentiate the first bracket. Now you differentiate the second one. Differentiate 2x, you get 2. Differentiate 1, you get 0. So differentiate the second bracket, you get 2. Then the other one, you just keep, don't do anything. So do you know how to differentiate two factors? First,
Yes.
okay. If you want to differentiate, you differentiate this, then keep this one. Keep that. Then this is the first part. Second part, you differentiate this one, then keep the other one. Then you write down. And you add up the two terms together, and that will be the answer. Okay? So one more time. You differentiate the first bracket, you get this. You keep the second bracket, you get this. Differentiate, keep. Then this second term is, you differentiate the second bracket, you keep the first bracket. Differentiate the second one, then you keep the first one. So it's alternate lah. Differentiate one, keep one, differentiate one, keep one. Then you add them up. That will be the answer. So I multiply out 1 times 2, 2x. 1 times 1, 1. 2 times x, 2x. 2 times 3, -6. Then you add them up. So this is the answer. 4x minus 5. Can understand how to do the differentiation of product? Cannot, then I repeat. Got two. Differentiate, keep. Differentiate and keep. So alternate. Then you add them up. You have to add them up. Yeah. Add them up. So add them up. Okay or not?
And one more time.
One more time. One more time. I show you another one. Right? Now we have two terms. 1 and 2. So what I want to do is now I differentiate the pink color. I keep the brown color. Then I differentiate the brown color. I keep the pink color and add them up together. That is the answer. Why I need to do like this? Because I have two factors. I have two brackets there. So I have to do like this. You cannot say differentiate this, then differentiate this, and that is the answer. No, not like that, right? Because there's a bracket there. Okay, right. So we look at the pink color. We are going to differentiate the pink color. 3 bring down become 6. 3 less by 1 become x squared. And this 1 minus 5x, you just keep. The brown color, you just keep. For the second part, you differentiate the brown color. Differentiate 1, you get 0. Differentiate negative 5x, you get negative 5. And which is the one that you should keep? You keep the pink color. So you keep this. Then you add up the two terms together. But you need to expand before you can simplify. So you expand 6x multiply 1, 6x squared. 6x squared multiply 5x, negative 30x cubed. Negative 5x times 2x cubed, 10x cubed. This one you just copy down. There's only one term like this. There are two terms with x cubed. You add up the two terms x cubed, you get negative 40x cubed. So to make it easy for you, I put two different colors there. One pink color and one brown color. You differentiate the pink color, you keep the brown color. Then you differentiate the brown color, you keep the pink color. Don't do anything to it. Just copy exactly the same. After that, you add up the two terms. That will be the answer. So that is the method. But then what is pink color, what is brown color, they can change. They can change the function inside the pink color and the function inside the brown color. So you look through, then you see whether you understand what I'm doing or not. Can or not? Can follow? If can, then you have to show me how to do one. Okay, right. So now you show me how to do. I choose one question like that, then you show me how to do. Let's say this one. So this one, using the product rule. You see number 2A there? So this is the pink color, this is the brown color. So you show me how to do number 2A. Okay. This one. you refer to this one, huh? Example number 1. Refer to example number 1. That's what, how to do 2A. Have you copied down the question?
Not yet.
You copy down this question, 2A. You finish, then I go back to the previous page so that you
Okay.
can refer. Finish copying.
Okay.
Okay,
Yes.
then you refer to this example. Pink and brown, okay?
Uh,
Yes.
not really understand why times 1 and times 2.
Which one? This one.
Yeah, first and
Oh,
no, the first example.
first example. First example, this one.
Yes.
There are two terms here, two brackets, the pink color and the brown color.
Mm.
Differentiate the pink color, you get 1. Brown color, you keep copy exactly the same. Then plus brown color, you differentiate. The pink color, you copy down the same, exactly the same. Don't change anything. Then you just add them up. That is the answer. This one. Pink color, you differentiate. The brown color, you copy down the same. Plus brown color, you differentiate. Pink color, you copy down the same. Then you expand and simplify, you get the answer.
But if differentiate like 1 not means 0 meh? Like just
Which one?
1
Example
also.
1, example 2,
Example,
or the
example,
number 2A?
example 1.
Example 1. Example 1, differentiate.
Not
Ah,
like just single number like 3 not differentiate, not like become 0.
3 becomes 0. So when you differentiate 1, differentiate x, it become 1. Then minus 3 differentiate becomes 0. So answer is 1. That's how you get the 1 here. That's how you get the 1. Then this thing, you just copy at the back. Next one. Differentiate
No.
2x become 2. Then plus differentiate 1 become 0. So answer is 2. That's why you get
Oh,
the 2 here.
yeah. Okay. Then go back the example 1. Why the not 1 times x minus 3 meh?
Y times x minus 3. This one.
Why the x minus 3 differential not become 1 and then 1 times x minus 3?
Oh, no. You differentiate the first one, then keep the second one. The second one is you differentiate the brown color, you keep the pink color.
So I differentiate the pink color and then I use the number to times the brown color.
Correct.
Oh,
Then the second one is you interchange. differentiate the brown color, then multiply with the pink color, change. The second one.
Send already.
Okay, I check, yeah.
Ah,
Well, here's the question. I have to refer to the question. So negative 2x, negative 2x, 6x plus 1, negative 2x. Oh, wrong. This is wrong, right? Now, why is it wrong? Why is it wrong? If you look at it, this one, you differentiate the first one, you don't multiply with the first one. You differentiate the first one, you multiply with the second one.
yeah,
Okay?
I do already. 6 times 1 minus x2.
Where is it? Oh, the second one. Okay. Now, if you look at this one, you differentiate this is 2, correct? This is correct, right? This is correct. This is correct. Differentiate 1 minus 2, 1 minus x squared is negative 2x is correct. So this one you differentiate, then this one you wrong. This one is wrong. This one you should keep the 6x. This one should be 6x plus 1. Should be 6x plus 1.
No, I do at the you see the second line.
Where?
under there. The 6.
1, 2, 3. Which one? 1,
1.
1. 6x
No,
minus
sir. The 4.
4.
Uh,
6, 1 minus x squared. This is correct. This is correct. Then this is wrong. This is not negative 2. This is negative 2x.
okay.
Differentiate
Oh.
x squared. Like here, negative 2x. Here you put negative 2, right? So you expand this is negative 12x squared, negative 2x. Okay, the first bracket is correct. The second one, you should have x squared and 2x. So x squared, 2x, 2x. So you arrange them again. So it's 6 minus 2x. 6 minus 2x. This one is minus 18x squared. Okay. So this one, since cannot, then we try another one. Try another one. Oh, this one more difficult. I try the C. You try number 2C. You try 2C. If correct, then we can move on. If not, copy down this question 2C.
Okay.
Then you refer to this one again. Okay or not? Can or not?
Can.
Okay. No.
Can.
Finish, you send to... okay, I check. I check the question first. The question is x cubed minus 5, x squared minus 2x minus 8. X cubed minus 5x squared minus 2x plus 8. Okay. Differentiate this this one. Differentiate this one. Keep this. This is correct. Then you differentiate this 3x squared. You keep this. Then this one come from where? Okay. Okay. Okay, right. Now, where is it? Okay, this one. Now, differentiate this. You have this, correct. Then this one you keep, also correct. Then you differentiate this one, 3x squared is correct. Then you keep this one also correct. Why this thing at the back there still got one more like this? This one no more already. This one don't have. This one don't have. Only 1, 2, 3, 4. That's all. Okay? Because this one is actually 3x squared already. This one is actually 3x squared. Right? Then you expand this one, you expand. This is the bracket, you know. This is the bracket. This is the bracket. So you have to expand this quadratic. This one you multiply one term. So x squared 2x multiplied by x cubed is x to the power of 4. You continue from here, can or not? You continue from here. 1, 2, 3, 4. This one you expand. This one you expand. Then you tell me, this one no more already. Just like this.
I do the arrow. The one, the x minus 3, I just now I differentiate there. I wrote there just now.
Okay. Okay, this one from here, okay. This one multiply become 2. Oh, this one. This is 2x, 10x. 10x is correct. This is 2x to the power of 4. This is 2x to the power of 4. 2x to the power of 4. Then 10x to the power of 5, correct? This one is -2, this is +10, correct? This one multiply 5, 3x to the power of 4, 6x, 24. Oh, this is correct, sorry. This one, don't know, you include this inside or not?
No.
No, okay, then it's correct. Everything is correct. So we can carry on with the next question, okay? Okay, wait. Okay, correct already. So now, what is this? Okay, now we carry on. Okay, so what we have been doing here is purely product rule. But now I want to combine the product rule and the chain rule together. That is something very difficult. Can you see that this is the product of two? This is the product of two functions, right? 1, 2. But the second function is actually a composite function because the bracket raised to the power of 4. And you cannot expand them using binomial theorem. You have to differentiate straight away like that. So this is the composite function. and this is the ordinary function. So again, I separate them into two colors. The 2, I just leave it there, all right? Then the x is the first function. Then 1 plus 3x to the power of 4, that one is the second function. So I proceed by differentiating the first function. The x become 1. The second one, I just copy down. You understand? Then the second one, 2 is still 2. Then the x is keep the x. Now I differentiate the brown color. Differentiate the brown color is you have to differentiate using the composite function. Bring down the power 4, power less by 1, then differentiate inside the bracket. Multiply them out. 1 plus 3x to the power of 4. Then this one multiply, 24, 1 plus 3x to the power of 3. Okay, so this one involves factorization, and